Recent observations of the interstellar object known as 3I/Atlas have drawn significant attention from the astronomical community after scientists detected what appears to be a faint bluish hue developing around the comet. This subtle but intriguing color change follows a rapid and unexpected brightening event that occurred while the object was largely hidden from Earth's view behind the Sun. What makes this development particularly compelling is that it marks the third time since the comet's discovery that researchers have observed a potential shift in its coloration, though none of the previous changes have proven permanent. These repeated transformations are raising new questions about the physical and chemical processes taking place within this rare visitor from beyond our solar system. 3I/Atlas holds a special place in modern astronomy, as only the third confirmed interstellar object ever observed passing through our solar system. Discovered in early July, the comet was seen racing toward the Sun at an extraordinary speed of more than 130,000 miles per hour, underscoring its origin outside the gravitational influence of our star. Its hyperbolic trajectory and extreme velocity make it clear that this object is not bound to the Sun and will eventually continue on its journey back into interstellar space. Scientists believe that 3I/Atlas may also be the oldest interstellar comet ever detected, with estimates suggesting it could be more than 7 billion years old. If this is correct, the comet likely formed around an ancient star system early in the Milky Way's history before being violently ejected, possibly due to gravitational interactions with large planets or nearby stars. After its formation and ejection, 3I/Atlas would have spent billions of years drifting silently through the cold, dark expanses between stars. During this immense journey, it would have been exposed to cosmic radiation, interstellar dust, and extreme temperature variations, all of which may have altered its surface and internal composition in ways that differ significantly from comets native to our solar system. Its eventual encounter with our planetary neighborhood offers scientists a rare opportunity to study material that originated around another star, effectively turning the comet into a time capsule from a distant and ancient region of the galaxy. In early October, 3I/Atlas made a relatively close approach to Mars, providing astronomers with a valuable chance to refine their observations and models of the comet's path and behavior. Shortly after this encounter, however, the comet moved to the far side of the Sun relative to Earth. For several weeks, this positioning rendered it largely unobservable from ground-based telescopes, as the Sun's glare overwhelmed any faint light coming from the comet. Despite this limitation, a small number of space-based observatories and solar monitoring spacecraft were still able to track the object indirectly, collecting crucial data during a period when direct Earth-based observations were impossible. The comet reached perihelion, its closest point to the Sun, on October 29th. At that time, it passed within approximately 130 million miles of our star, a distance about 1.4 times greater than Earth's average orbital distance. Although this is not an especially close solar approach by cometary standards, it was close enough to subject the object to increased solar heating. Surprisingly, data analyzed from spacecraft observations revealed that 3I/Atlas underwent a dramatic increase in brightness just before perihelion, brightening by several orders of magnitude. This sudden change was unexpected and could not be fully explained by the gradual warming typically associated with a comet approaching the Sun. Alongside this unexpected brightening, researchers reported something even more unusual. The comet appeared to be distinctly bluer than the Sun itself. This observation stood out because earlier measurements had not indicated any such coloration. The researchers proposed that the bluish tint might be caused by the release of specific gases from the comet's nucleus, such as carbon monoxide or ammonia. These gases can emit or scatter light in a way that produces a blue appearance, especially when illuminated by sunlight. However, the study presenting these findings has not yet undergone peer review, and no independent observations have confirmed the blue coloration so far, meaning the results remain tentative. The apparent blue color contrasts sharply with the comet's earlier observed hues. When 3I/Atlas was first discovered in July, it exhibited a noticeably reddish tint. Astronomers believe this red coloration was likely due to a significant amount of dust being released from the comet's surface. Dust-rich comets often appear redder because dust particles reflect sunlight in a way that enhances longer, redder wavelengths. This suggested that, at least initially, the comet's activity was dominated more by dust than by gas. Then, in September, observations indicated yet another temporary shift in color, with the comet appearing to take on a greenish tint. Green comas are relatively common in comets and are often associated with the presence of certain carbon-based molecules, such as dicarbon or cyanide. When these molecules are energized by sunlight, they can emit green light, giving the coma its characteristic color. As with the earlier red hue, however, this green coloration did not persist and eventually faded, returning the comet to a more neutral appearance. The fact that 3I/Atlas has exhibited red, green, and now potentially blue hues over the course of just a few months is highly unusual and suggests a complex and evolving pattern of activity. Each color change likely reflects a shift in the balance between dust and different types of gas being released from the comet's nucleus. These shifts could be driven by changes in solar heating as the comet moves along its trajectory, or by the exposure of new layers of material as surface ice sublimates and cracks form. Another possibility is that the comet's long exposure to interstellar space has resulted in a highly layered or chemically diverse structure. As the comet warms during its passage through the inner solar system, different volatile compounds may be activated at different temperatures, leading to temporary bursts of specific gases. Once those volatiles are depleted or the local conditions change, the associated color signature may fade, explaining why none of the observed color changes have remained stable over time. Despite the excitement surrounding these observations, many questions remain unanswered. The precise cause of the comet's sudden brightening near perihelion is still unclear, as is the true nature of the reported blue coloration. Without consistent, repeated observations from multiple instruments, scientists cannot yet be certain whether the blue hue represents a genuine and lasting change or simply a brief and localized phenomenon. As the comet continues to move away from the Sun and becomes more accessible to Earth-based telescopes, astronomers hope to gather more detailed data that could confirm or refute these early findings. Continued monitoring of 3I/Atlas will be crucial not only for understanding this individual object, but also for improving our broader knowledge of interstellar visitors. Each new interstellar object provides a unique glimpse into the diversity of planetary systems beyond our own and challenges existing models of comet formation and evolution. Whether or not the comet's latest bluish hue persists, the repeated and varied changes already observed make 3I/Atlas one of the most scientifically intriguing interstellar objects ever detected. Only time and further observation will reveal whether its current appearance marks a lasting transformation or just another fleeting chapter in the long and complex journey of this ancient cosmic traveler.